Hey everyone. My name is Billy Autrey. I am an implementation engineer at a company called EngFlow. I'm guessing nobody here has heard of EngFlow, maybe a few people. One of my coworkers is back there. And what I'm going to talk about right now is how tech giants build code at scale and how that sort of relates to developer productivity as a discipline. But one thing you probably noticed is if you've never heard of EngFlow, how do I know anything about how tech giants build code at scale? And in fact, if you look at my job history, EngFlow is not a tech giant. Gemini, you could maybe make the case, but I'm guessing half of you haven't heard of Gemini unless you're really big into crypto. And Lightband also is not a tech giant, so why am I qualified at all to talk about this? Well, the companies that I worked for were typically startups that were selling to major corporations and selling to these sort of tech giants. And so typical customers on the left for either of those companies sort of mixed and matched. And then the people in my network, EngFlow is actually a third of the employees there are ex-Googlers. And I've got people in my network that have worked or do work at Twitter/X, LinkedIn, Databricks, Salesforce, you name it. And so I guess what I'm saying here is that through my relationships and through the people I talk to and through the things that I do day to day, including working with remote execution and building at scale with EngFlow, I have hands-on experience with this sort of developer productivity march, this sort of discipline. And this is not just me talking about things in the air that I Google. This is partially my own experience and the experience of my cohorts who are much smarter than me. So let's talk about a little bit of a tour of developer productivity strategies. I'm not going to go into too much detail about these right now because we'll dive into each of them as we go. But just a general tour, what we're going to talk about today, I'm going to talk about monorepos. I'm going to talk about AI and developer productivity. Cloud developer instances, that's a really popular topic right now. Build tooling in general, so EngFlow is remote execution and remote caching, and the build tooling is a big part of that. So Bazel and Buck2 and those sorts of tools are really big in developer productivity because they correlate. So that's sort of where the end of the journey is for us today, kind of playing on the previous speaker, is the end of the journey is talking about remote execution. So why do we have all these different tools? Why do we have these disciplines? Why go to all the trouble to spend so much time and energy talking about developer productivity? Well, some of it's just because of resume-driven development. People like to put neat new things on their resumes. And so it's just pretty common for people to, well, I heard Bazel is cool. I want to work with Bazel. So yeah, I'm going to recommend it or move to a company that does this. And that's a way to attract talent sometimes. The cargo cult is real, so sometimes people copy-paste techniques and things just because it seems interesting, like, oh, well, Google did it. I don't know why they did it, but I guess I'm going to do it, because they made Bazel, so maybe the reason they did Bazel will become apparent when I do it, so I'm just going to copy that. But the real reason is that developer time is really expensive. So, developers, people who work in tech, they tend to make a lot of money, which means the amount of time that we spend in tech sitting around is expensive, and companies want to minimize that time as much as possible. And frankly, I kind of ascribe to this idea of dopamine-driven development. I like to solve problems because it makes me feel good, and I want to keep doing that. And the more that I can, spend time fixing problems or figuring out if what I did is correct instead of just waiting for things to compile, the better my time is spent. So, companies really want to play into that, and that's why developer productivity sort of arose as a major discipline in the tech giants. So waiting around is obviously bad. So how do we use technology to solve this problem, right? Obviously, automation. If we can automate things as much as possible, that will help. So let's look at some of the problems and figure out how we can, solve them with technology. This is the secret theme of my talk today. It's a quote from Jimmy Zawinski. He worked on Mozilla and Netscape. The idea is, oh, I know, I'm going to use this new technology to solve this problem. Congratulations, you now have two problems. That's, yeah. So problem number one, coordination is hard. So if you have two teams kind of talking about things, you have, maybe they are working on two different services. Those services have to talk with APIs and things, right? So it's, in order to make sure that the APIs don't break between things, I might have to have meetings. I might have to make sure that they're on the right version. We have to coordinate when our versions deploy. With one other team I'm working with, that's not too bad. You add one more team, and suddenly the amount of coordination I had to do doubles. Each team has to have twice as many meetings and twice as many coordinations, and it's like organizing a meeting with your boss. There's no time on his calendar. You get to 5 teams, and suddenly, we're summoning the devil or something over here. We've again doubled the amount of coordination that you had to have, right? There's so much talking there. And then you can imagine if you get to Google scale or Uber scale or anything like that, you get this. Does anyone recognize this? What this is? This is a circa 2018, I believe, real diagram of the microservice architecture at Uber. There's a blog post on it and everything. This is all of the microservices that they had and all the interconnections that they had. So you can imagine how many meetings is that? Right? It's a lot. It's a lot of time wasted. So the fix for this is monorepos. What does that mean? So if you imagine, like having meetings to try and figure out what versions are being deployed, and if you get that wrong, the cost is you find out in production that you deployed the wrong thing, and you find the bug in production, and things crash, and it's a bad time for everybody. So ideally, you want to push all of that to the developer time. I want to discover much earlier that everything is sort of broken. So if you put everything in one giant repository, then you can find everything at compile time. That's a lot easier. Maybe. We'll find out in a minute. The other thing is that if there's this sort of discipline of CI/CD, continuous integration, continuous development, or deployment, sorry. As you want to deploy what's at head on your repository continuously, and if the whole code base is in one repository and you deploy everything at head, you don't have to worry about coordinating everything. The right version that does work gets deployed to all of the services at the same time. So as long as you deployed head and you have this big repo, it all sort of dovetails together, and you get this sort of, it doesn't eliminate all meetings, but it helps eliminate a lot of meetings and discover a lot of problems at compile time instead of runtime. So no more version hell there. And this is not just a weird idea if you've never heard of monorepos. This paper is from 2016, I believe, July 2016. It is in ACM, in a prominent computer science journal. Google does this, and you can imagine how much code they have between now and 2016. They've written a lot of code since then. But they store billions of lines of code in a single repository. They make it work. The paper is fascinating. I recommend reading it if you want to know more about monorepos. There's a link in the corner. I don't have a QR code for that, but the slides will be available later, I'm pretty sure. Yeah, you have a question?
Actually, a comment. All of Facebook is in one repo.
Right. Yeah, Facebook is also in one repo. Yeah, there's actually the slide that I had before, the right side. Almost all of those companies do monorepos. In fact, I think I have a slide about that later. But there's way more companies than you think that are doing monorepos. So Google, I think, was maybe not the first kid on the block doing this, but they were the one who made it seem like a really viable idea. And everyone else in Silicon Valley kind of took off with it. And so there's a huge prevalence of monorepos in tech giants today. And I also know this because we work with a lot of these companies. In fact, Facebook wrote Buck 2. That's the other build tool that I kind of talk about. Buck 2 is inspired by Bazel and uses some similar ideas. So you remember our secret theme here is, congratulations, you have a new problem. Well, it turns out monorepos are actually pretty hard to work with. This is a word cloud of all of the different languages and tools that Bazel has extensibility for, so rule sets. And so you can imagine, what if I had to have Docker, build Docker containers and Python and Java and C++ and Go and Scala and iOS apps, and I had to have the same tooling and the same monorepo do all of those things all at once. It can be pretty complicated. Like if I'm a Java developer, I don't want to have to build somebody else's Python service just to figure out if my service can talk to theirs. That's a mess, right? I don't want to know how to compile Python. I don't understand the errors. I don't know what went wrong with all that stuff. So it can be pretty tricky to reason about. So when you're thinking about, part of this talk is about developer experience. So when you're thinking about a monorepo with all this code for all these different developers, you start to wonder, well, how do I teach everyone, how to use these different compilers? Which compiler do I actually use? Is there like one magic compiler that compiles everything? No. How do I get all of the new developers set up? So imagine if I had everything on that word cloud, that had to be required as a new download for new developers, that would be insane. It would take like weeks for a developer laptop to get set up. The reality is sometimes people like monorepos so much they decide to have 2 of them or 3 of them. So how do you get multiple giant repos talking to each other? What do you do with versions of things? What if you have Java 17 and Java 21 compiling in the same repo? How do you get there? The code complexity starts to get really, really problematic as you increase the size of the repo. And the other thing is, if I have a giant repo and I have billions of lines of code, does that mean that every time I want to run something like that's a common library, do I have to recompile everything? That's going to be a huge pain. So let's talk about the different solutions that we solve for now with monorepos. One of the approaches is, let's use machines on the cloud. Right? This problem of how do I install all these different tools, it becomes a lot easier if you think about like cloud, AWS, they have AMIs, these pre-baked images, so you can just pre-bake your developer instance and throw it on the cloud, and then boom, you don't have to have giant beefy laptops for all your developers. They can just, start up a new dev instance, run it on the cloud, and that's when I run to compile everything, right? But the problem is that as your code complexity grows, you get this beefy machine, well, it's got to get beefier. And it's got to get beefier, and suddenly, you're paying for every developer, 64 cores and a terabyte of RAM. It's a problem. This solution works at a certain scale, but once you surpass that scale, it's only one tool in the toolbox. It's not sufficient to solve for everything. Another problem. This is a hot topic for some reason today, probably because it's a hot topic in Silicon Valley. Let's throw AI at the problem. How do we throw AI at this problem? Well, obviously, to save time, our ultimate goal here is to make developer experiences better and to save time. So if we throw AI at the problem, then we would just, hey, AI, tell me what things do I need to build and how do I build it, right? Well, the problem with this approach is that AI takes a lot of energy to sort of run, and it also takes a lot of energy to train that model. And so you have to continuously train it, you have to continuously run these calculations, continuously feed it information about your tree that is constantly changing, like every day, like thousands and thousands of commits, millions of commits, even if you're at Google scale. And it has to train on all of this and make the calculations right. And what happens if the AI is wrong? Any guesses there? Bugs. Yeah, you get things like if it decides, oh, you don't have to run this test, but it turns out you actually did have to run that test, and it doesn't catch a bug, that bug gets all the way to production, gets deployed, and then you have an outage, or you have you sent money to the wrong person, or something like that. And just to make this a little real, I'm going to pick on ChatGPT because I know we talked about it earlier. We may get to the point of intelligent AI, but even intelligent humans make mistakes, and sometimes ChatGPT makes mistakes too. Very subtle mistakes unless you happen to read what it's doing instead of just copy pasting it. So the square root of 8 is not 2, spoiler alert. So how does build tooling come to the rescue here? How does it solve some of these problems for us? So on this slide, I'm talking about these blue sections here. These are some of the problems that I talked about before with monorepos. Right? So which compile tool do you use? What would we want out of a build tool? I would want it to support tons of existing compilers, infinite compilers maybe. Meaning like I would want it to support the most common compilers, and then I would also want to be able to extend it so that if I had a new language come up, my build tool doesn't suffer because of it. So developers have the freedom to pick new tools. How do I set up new developers? I don't want every developer to have to download everything and figure out what version to download and have all this sort of mismatch. I would want the tool itself to sort of figure that out for me, right? The reality is we can't have just one monorepo. Every monorepo place has multiple repos, so I'm going to have to access other repos as code as well. So I want integration between repos to kind of have a virtual monorepo. And I also am going to want to be able to support different versions, or at least be explicit about it so that I know what version I'm working with in the particular library or target that I might be trying to build. And so this is where we start to talk about Bazel. I'm not going to go through the whole history here, but the idea here, what you should get out of this slide is that this evolved sort of over time out of need from Google as their monorepo grew and grew. They went from make files to generating descriptors about makefiles to sort of generate makefiles, to then let's make a whole language so that we can parse and extend the flexibility of build files, all the way to remote execution and remote caching. So actually, Bazel is really interesting. My company is kind of the Bazel company because the guy who led the team who built Bazel for most of this period is our CTO. So yeah, pretty cool fact. And back to what he was talking about, Facebook. So Facebook is not a Bazel user. They use Buck 2 and Buck as well. They're migrating to Buck 2 from Buck. But if you look at this list, I went and Googled. Some of these are customers and known customers of EngFlow, but others I just happen to know are Bazel users because they have talks about going to Bazel or migrating to Bazel, or they're went to BazelCon talking about it. And these companies typically aren't just using it in one section. They're usually using it for giant sections of their developers' ecosystem. So Spotify, for instance, I know that they use Bazel for some of the apps that they build. You can imagine how big the teams are that build the Spotify app on your phone. Etsy uses Bazel pretty famously. BMW Group uses it pretty famously for some of the in-car systems. Airbnb has articles about migrating to Bazel. Snapchat has articles about Bazel. They're doing really interesting Bazel stuff, actually, from what I understand. Tinder actually has rules, so they're contributing to the Bazel ecosystem. So they're not only just using Bazel, but they have a rule that lets you reason about what has changed between different commits in Bazel. So all these companies are fully committed to Bazel and the monorepo vision. Go ahead.
Salesforce, I remember, actually has a whole team internally dedicated to training their developers. So I just wanted to put that one out.
Yeah. Salesforce is highly committed. Yeah, we met some of those people. They hosted BazelCon or Bazel Community Day in Munich last year. And they have a full education system, and so does Google, so do many of these companies, dedicated to teaching people how to use Bazel, as well as 10% of the developer force is dedicated to developer productivity to maintain these systems. So it's a really big deal. Developer productivity is a huge discipline, a huge area. I pivoted my career to it, and I've been very happy about it. So examples. So let's talk about how Bazel actually does the things that I just talked about. How does it solve these problems that I was talking about? So Bazel is extensible. It does let you declare rules, external rules, and you can import them into your workspace. So for my repo, I can sort of mix and match the different rules and sets of rules that I use. And then you can think of tool chains as the version of the compiler or some other thing. It's essentially like dependency injection. So if I'm using a rule, the tool chain can be used to inject in information about, okay, well, I know that I'm on a Linux system, so I need to download the Linux Java compiler to compile this Java library. So the tool chains kind of let you intermix and solve automatically for those sorts of problems so that any developer on any system can just download the repo and then go Bazel build, and it works, if it works well. Tool chains affect inputs. So this way, I'll talk more about this in a minute, but the idea here is that you don't want a cache entry for C++ built on Linux to then try to run on your Mac. There's different architectures that won't work. And so the tool chains affect inputs so that Bazel is smart and automatically knows, hey, this binary won't work across these different systems because the tool chain is different. Ideally, you only have to install Bazel. That's the developer experience that you actually want. So I would want just my developers to download Bazel and then hit Bazel build, and it should just work. In actuality, you do also have to download a Java runtime, and typically you download Basilisk, which is like a tool to manage the version of Bazel. But it's 2 installs, but after that, you're off to the races. Ability to access other Bazel repos as dependencies, that is something that Bazel does. So you have 2 mechanisms to do that. You can either access it directly as a Git repository, or you can download the code base as an HTTP repository and like a snapshot in time of the repo and then compile that. And then by default, Bazel is opinionated, and it kind of nudges you towards having a single version of things. But if you want to, you can declare multiple versions. It gets trickier when you get down to tool chains, though. Like if you have Java 17 and 21, that's a lot harder to do. But it does support transitions and things like that to be able to use multiple versions of things if you want. So I apologize if this is hard to read. I wouldn't worry about this too much, but the idea here is that this is a sample file system of what a repository with Bazel might look like. So typically Bazel people will put different source code languages in different folders, and in those you have whatever your structure should look like. And then there's these build.bazel files. These files are the Bazel build descriptors that allow you to sort of construct the building blocks of this is what this library looks like, and here's what the source files look like, and here's what the dependencies are. So you can declare all those inputs and the rules to then tell Bazel this is what the dependency tree will sort of look like. You don't have to describe the whole tree though. You just tell it that for this set of code, I need these dependencies, and these are the input files, and it's a library, so I want you to build it, and it'll build a jar out of it. Bazel will inspect your tree in your workspace, and out of all of this, it will decide, oh, okay, well, this is sort of what the tree looks like. I know that Java source server is a server, and because the build file declares it to be a Java library, I'm going to use Java-C for it. And the same for the client. And then this is a TypeScript library, so I'm going to use TypeScript compiler for that because they use rules TSC for that. And then for this one, I use rules CC for it, so I'm going to use GCC to compile this one. So Bazel, with the build files and the workspace declarations and the rules, automatically has this picture in its head of these are the targets I'm building, and this is what the tree should look like. What it does after that is it puts together that workspace, and that I talked about this a second ago, but here's a better visualization for it. The workspace here says, okay, for Java, I'm declaring Java 21. Over here, I know that this rule uses Java-C, so that means that I'm going to make sure that I have Java 21 for my operating system, which is Debian. I'm going to make sure that all the dependencies for that are compiled, and then I'm going to, at the end, call Java-C on whatever this client is and generate the jar file. Each of the things here, like compiling the client, might be like 50 actions of making sure all the dependencies are compiled and their dependencies are compiled and so on. But each of those is cacheable. I'll talk about the caches in a second. But this means that for this Java-C, if all I changed is the actual client file and I have the rest of the stuff cached, I don't have to reboil the ocean every time. I just have to compile the piece that I actually care about, and it will make sure the rest is sort of there already. Well, later is now. So the way that the action cache kind of works in Bazel is every action is cacheable. So the building blocks of a dependency tree are actions, and every action is cacheable. And the way that it does this is it takes all of your inputs and including the tool chains and the flags that you use, because the flags can change the outputs. It takes all of that information and it considers them all inputs. And out of that inputs list, it generates a tree, or a hash, sorry. This hash is like a key. You can think of it like a hash map, where the key is the hash of all the inputs, and the value is your actual artifact that you build, the jar that you build at the end. And so what this does is, instead of inspecting your tree with AI and trying to figure out, well, I think you shouldn't have to build this, it doesn't do that. It just uses pure hard math. Like, the hash is always the hash, and it will match or it won't match. And if it doesn't match, I build it again. If it does match, it's a cache hit, and I can look up the value. And it works across OSs. It works for different flags and things like that. And so the idea here is that if we're just calculating a simple hash for inputs, then it's going to be fast and correct. But you don't have to take my word for it. You can actually look at the Bazel front page, and it says fast and correct right there. So, yeah. Yeah, sure. SHA-256 by default. There is some support for Blake 3, but it's not everybody extends that support all the way to the remote execution platform. But locally, there's an experimental feature to turn on Blake 3 support, and so does that help? Yeah, cool. Remote cache. So this is pretty cool. If you can imagine, okay, if I'm just building stuff, if I haven't pulled master in a long time, and then I do pull master finally a week later, if I'm at Google, there's a bunch of changes. I'm going to have to recompile everything. This is going to take forever just because I'm out of sync with what's real on master. So at Google, what they do is they have a remote cache, which is everybody, or on master, the code is compiled over and over and over again, and there's like a remote disk. You can think of it like S3 on Amazon or GCS, a GCS bucket or something like that. As a simplified way of doing it. It's actually a service in a lot of other companies. But this remote cache is like a remote disk that has everybody's freshest compiled code and all the versions in between sort of cached, so that instead of me cloning later and getting, having to recompile everything, I can just depend on the remote cache and get it. And to kind of see this in action, here's like an example. So if you can imagine, like, if I'm building something using an API framework, I might have the API defined here, and then my client and my server are both going to depend on it. Does this pattern look familiar to some of you? Yeah. Okay, so that's a very small dependency tree. So if I'm changing the client, right, I do a git branch off of this commit, and I change a client, right? Well, my teammate changes the API, and then there's some other commit where something else changed, and they check in their change to the API before I get finished. Well, because I'm a good developer, before I try to merge the master, I either merge in master or I rebase off of master, and at that point I pull in this API change, and what that means is I have to rebuild everything. I have to rebuild the API, I have to rebuild the server that has nothing to do with what I'm trying to do, and I have to rebuild the client. So not fun. If we have remote caching, I only have to rebuild the client. I don't have to rebuild the server, and I don't have to rebuild the API. And the reason is because each of these commits, when they get built off a master, they go into this remote cache, and I can just fetch those results. And then I only have to recompile the thing that I actually changed. Does that make that remote cache idea more clear? Is that cool? Finally, I do want to talk about remote execution. So earlier I talked about when you're compiling Java-C or your client or whatever, it may turn into 50 or 100 actions. Well, each of those actions is a small building block. If I'm doing this on my local laptop with only 4 cores, well, the 50 tasks I have to take turns across those cores, and it'll take a little while to do that. And so what Google did was, if you know anything about Google, the big thing that they do is commodity hardware and building things on small pieces and doing MapReduce. And so if you take that idea and extend it to compilation, you take each of those little reduced pieces, those actions, and if I run them all on a single core worker on AWS in the cloud or on in GCP, then I can essentially do my entire build in parallel, the whole thing. And it will also have its own remote cache up there, so it has an idea of all the files, and I have to upload everything to do it. And so the idea is remote execution is like a huge multiplier for how fast I can do compilation of anything locally and for CI. A little bit about the remote execution protocol. It's open source. It's built on top of gRPC because, of course, Google. And it's because it's an open source protocol, Bazel uses it. Facebook's build tool Buck2 uses it. BuildStream uses it. Twitter used to be on a tool called Pants, and it uses it, but Twitter since moved to Bazel. And many, many more tools use it. I know, for instance, of a famous build tool in the JVM ecosystem that is starting to build remote caching capability using the same protocol. So this remote execution protocol is up and coming. It's going to be more popular if you stay in this field. You're going to see it. And so this is my sort of wrap up here is, if you're curious to know more, if you actually want to know Bazel, if you want to get hands-on with it, I actually do this training. I built this training, and I have teammates that do it as well. So we do training for, hands-on training involving, real containers, real Bazel, or real repo. And remote execution, here's like some actual results. So Brave Software went from 2 hours down to 15 minutes with remote execution. A top 5 automaker went from 1.5 hours on their build to 19 minutes. Blue River Technology is a subsidiary of Deere. They went from 3 hours down to 20 minutes. So remote execution, parallel build is like a huge, huge time saver. And that's it. That's all I got. So there's my LinkedIn. There's my email if you want to reach out to me. There's my company's website if you want to go there. Any questions? Huh?
No questions?
Going behind you.
Do you know if Spiceworks uses Bazel?
The what?
Spiceworks? Because if not, that's a tragedy.
Oh. The question was, does a spice company use Bazel? The answer is I don't know.
What's your normal training time? What is your average training time for your teams that you work with?
Right now we try to do, so the Bazel Bootcamp, for instance, is a 4-hour course. The developer productivity course is probably going to be an 8-hour course. It's still in the process of being baked, and we're doing some timing and some fine tuning of it, but it's going to be probably a full day. And then the rules author course is probably, it's 4 hours right now, but it might expand as well depending on how much we add to it. So.
Yes, I do. So it seems like Bazel is mainly for mono repos or companies that adopt mono repos. Are there any other benefits of Bazel or remote code builds for people who are not using mono repos?
Yeah, I would say that Bazel does expose you to remote caching and remote execution in general. It's a little trickier. Like, you get less of that benefit if you're talking across a bunch of repos, because you're still sort of absorbing the problem of version health that you sort of save with mono repos. But Bazel remote execution, remote caching is available for anybody that's using Bazel, and so it does have that benefit of, yeah, I can do remote execution with my small repo. Yeah.
Are there any major differences between Bazel and Buck 2?
It's an interesting question. So Buck 2 is a very new project that Facebook started. The idea essentially around Buck 2 is, okay, Bazel is really great, but it has some quirks about it. It's written in Java originally. It has some built-in rules which kind of break the rules that other rule sets use. And it's it's got varying states of support for some languages. And so Buck 2 is like, what if we took Bazel and supported everything about it, but brought it from the ground up, built it from the ground up with no tech debt, right? And so Buck 2 is written, I believe, in Rust, so it's very fast, and it's depending on your local system. It uses the same build structure as a Bazel system. The idea is that you could, if you knew Bazel, you could just lift and shift your code base over to Buck 2. The reality, though, is that it's a very new ecosystem, so the documentation is still up and coming there. There's not as much training out there. There's not much training for Bazel. It's just what we do, really. But there's even less for Buck 2 at the moment. The ecosystem is not quite there because it hasn't existed for very long. And so it's very much a choose your own adventure / read the Buck 2 source code if you want to go that path. But some people are very adventurous, have a lot of tolerance for that sort of thing, and there are people who are getting quite successful with Buck 2. So that's the main difference, I would say.
All right, we're going to have a 10-minute break and then wrap up the day with our last two speakers. So give another hand to Billy.
Thanks.